Hello and welcome to our talk on our article, Black Belts and Machine Learning Can Be a Powerful Combination, a mixed initiative proposal for the advancement of digital transformation in manufacturing. My name is James Wells. I'm the principal consultant at Quality and Practice, a continuous improvement consulting and training practice. My co-author, Deepak Taraga, the senior vice president of data science from Odin Technologies, is also here. Manufacturing organizations have learned some hard lessons over the past couple of years. Prior to the pandemic, digital transformation initiatives were conducted mostly as casual, speculative experiments. But the pandemic has taught us some lessons about how we need to view these efforts. In 2018, Harvard Business Review reported that 1.3 trillion had been spent on digital initiatives globally, yet 70% of that, or 900 billion, had been wasted. This same study presented in Harvard Business Review highlighted the reason for the high failure rate in digital initiatives. It was largely the singular focus on technology. And this information is instructive to our proposal here today. An additional lesson learned from the pandemic era is that robustness and resiliency of operations needs to be prioritized for digital initiatives going forward. Digital initiatives prior to the pandemic were poorly structured activities, often performed without any involvement from operations personnel. These initiatives introduced some machine learning-based solutions, but they were unfocused and largely with no payoff. What has become clear is that the machine learning systems cannot be used in isolation from the operational teams if we are to solve important labor market and utilization challenges that we are faced with now and will continue to be faced with for the remainder of this decade.
So what we propose is an approach that combines the two. It uses data-driven machine learning directly in support of process experts and operational teams to accomplish these digital transformation initiatives. Now, in order to describe this approach, we co-opt the term mixed initiative. This was a term that was introduced in AI literature a while ago as part of how humans can interact with computers. And we believe that it is apt in today's world to re-enable that term when we talk about how machine learning can be used directly with our process experts and operational teams.
So our proposal combines the strengths of the black belt role and the machine learning, and additionally compensates for the weaknesses that each of those entities have faced traditionally in the old system. So black belts possess immense knowledge and are trained to analyze data in the pursuit of problem solving, but they have several constraints in their mission. Number one, they're constrained by the amount of data that they can process. The number of confounding variables can be great depending on the complexity of the process being studied, and the lack of real-time data.
On the other hand, there has been a lot of progress made with machine learning algorithms and their applications in real-world settings. However, machine learning in manufacturing specifically is constrained by a few things. First, there is lack of reliable data. There's just like so much different data that's being captured, but a lot of this data is inaccurate, may have gaps, and we're still not necessarily observing everything that needs to be observed about the manufacturing process. The second part of this is lack of reliable ground truth or labels. Labels are useful for machine learning models to be able to learn and extract patterns of interest. But in the manufacturing space, these labels often are also not as accurate as needed. The third part of this is that manufacturing is a fairly complex choreography of materials, people, machines, and processes. And really, there's a lot of inbuilt hidden context and relationships that are hard to discover when they're implicit in the data.
So those are the weaknesses. And then, so on the flip side of the coin, there are some strengths of the complementary method that black belts and machine learning have in their respective roles. So black belts understand the types of relationships and insights needed for transformational change. On the other hand, machine learning models can quickly identify patterns of interest by sifting through large amounts of data very quickly. In our mixed initiative approach, we leverage these jointly. We propose that the black belt defines the context and the objective, while the machine learning engine extracts relevant model candidates and patterns from the available data. Black belts then take those and attempt to validate them, and then the machine learning engine uses those to operationalize meaningful process improvements.
So in order to illustrate this approach, we picked a specific problem, and we call this problem the golden run problem. A golden run is basically a benchmark performance period where the process achieves some sort of best performance, where this best can be defined using a combination of the OEE parameters, things like availability, performance, or quality, or other aspects, including things like power consumption or costs associated with the process. And so really what we're trying to do is identify how to replicate this optimal golden run performance. And so what it requires is being able to analyze process history to identify this golden run, and associated with it what the process parameters and recommended settings are, so that we can reliably replicate this golden run. A mixed initiative approach to identifying golden run is illustrated in the figure on the top right. It's actually like a 4-stage process that starts with defining the context for the golden run, analyzing history to extract it, validating the golden run recommendations, and then deploying it and operationalizing it. Right? In the figure, we've shown this with 2 separate colors: blue to indicate stages that are driven by the black belts and domain experts, and yellow to indicate stages that are driven by the machine learning engine.
So in the first step, the black belts define the golden run context. And what they do here is they identify the characteristics or conditions that can affect the process based on their process knowledge and what they believe are the important relationships to uncover. For instance, conditions that can possibly introduce change to the process, things like product changes, seasonality, day, night, employee turnover and new employee training, raw material changes, and equipment maintenance are some typical things that might be context variables. Process knowledge informs this set of potential conditions, and it is necessary to fill in gaps that the machine learning engine and data alone cannot. Of course, the purpose of this stage is for the black belt to define the search space for the machine learning engine to then search for a golden run candidate. These conditions give context for the golden run, including the influence space of the golden run, such as is it relevant for a specific production run, a specific shift, specific product, specific season, or is it applicable across a broad part of the manufacturing footprint? The machine learning engine uses these to identify golden run candidates that can then be tested. Black belts can be expansive in the number of conditions and their combinations and relationships that the machine learning engine needs to explore. Black belts can also provide the objective for the study. The optimization objective identifies the best outcomes desired from the operation. For example, achieve fastest production possible while ensuring good quality continues to exist.
Once the black belts set the context, it's then the machine and learning engine's role to analyze this vast amount of history and extract golden runs. So this involves looking through the data that you've collected about your process history, being able to extract candidates. And what that means is like being able to extract patterns in the data that actually represent stable performance that's relevant to the type of optimization we need to accomplish. Once we've identified a few candidates, then search through the space of possible candidates to identify those, or sometimes synthesize those that best optimize the objective using a combination of machine learning and optimization techniques. And once we do that, then extracting the appropriate control parameters that differentiate this golden run from other candidate performance periods, because this then allows us to identify what needs to be controlled and the appropriated settings for those control parameters such that we can reliably replicate the golden run. Black belts are then provided with a set of potential golden runs that are extracted from the data.
In the third step of our process, the black belt is responsible to attempt to validate the golden run recommendations. So they take the candidate golden run suggestions from the machine learning engine and prepare to do a validation run. This validation might include deep dives into the data to understand the results, and also performing simple, straightforward confirmation runs. Confirmation runs are experiments to confirm results under the condition of interest. And we attempt in the confirmation run, we attempt to duplicate as close to exactly as possible the conditions under which the golden run candidate was produced. And the objective of the confirmation is to achieve similar performance or identical performance to the golden run candidate. This is confirmation that this golden run is repeatable in our operation. So in some cases, results may not be validated because of varying issues in the data or incomplete context that the black belt or the team has provided. In these cases, the team has to go back to the drawing board and really think about additional elements of context to fine tune and refine the golden run recommendation.
The fourth stage in this is about deploying the recommendation. So as the machine learning engine is provided contexts by the black belts, the engine builds out a library of golden runs. Each of these golden runs in your library represents a distribution of parameters and their control settings. And in addition to that, like as we are actually establishing our process, you actually have transitions between contexts, things like products changing, things like, material being changed, and so on. These transitions are also correspond to transitions in the golden run that needs to be established for that particular context. So what we really need to do to operationalize the recommendations is first to be able to identify which type of context we are in, so that we can actually deploy a golden run for that context. And then importantly, identify transitions between these contexts. So to be able to learn automatically when the context that you're operating under is shifting. Are we moving from a certain type of product to a different type of product that then allows the control algorithm to select the appropriate golden run from the library, use that to set up the process and achieve optimized performance under most conditions.
And of course, this is an iterative process, and until trust is built in the automation, black belts can continue to support the operations team with coaching as these transitions occur. Of course, there's a continuous learning cycle here, and the library can be refined and updated as the operations team learns additional things and adds additional contexts to their understanding. So digital is only partially about technology. I talked at the beginning of this presentation about a Harvard Business Review report, which showed that 70% of those efforts that failed in 2018 was largely due to a singular focus on technology. So digital is only partially about technology. It's really mostly about people. The nature of work will change as technology adoption increases. Perhaps also unique to this moment in time is a demographic shift happening in the workforce at the same time as this digitization effort is happening. As millennials enter middle management and Gen Zers enter the workforce, understanding of possibilities and expectation of technology increases. The process of operationalizing autonomous operations will accelerate. The graph on the left side of this page represents the impacted workers by digital transformation initiatives. And the size of the bubble is the population, and the proximity to the top right corner of the graph means those populations will be impacted sooner than others. And as you can see, production workers are the third largest group, and they're in the top right quadrant.
The process of operationalizing these autonomous operations starts by leveraging such a mixed initiative approach. So we have to leverage this approach to build out a library of trusted recommendations and that the machine learning engine can generate, and simultaneously train operations teams on how to interpret these recommendations, take action, and then additionally, like, complete this loop, refresh the context for the machine learning engine. We believe that as millennials and Gen Zers move up in the organizations, this trust will pay off as they identify operations and steps that can be turned over to the machine to control. Success in this transfer is only going to feed more opportunities to both improve the models that makes them stronger, and then eventually lead to a self-sustaining digital control process.
We thank you for your time and attention today to this important topic. Of course, if you have questions and you want to follow up with either Deepak or myself, you can reach out to us with the information that's provided on this page. Thank you very much for your time today.
Thank you.